Alright, hello everyone, welcome back to my channel. So today I'm going to solve a problem, evaluate division. So this is also a graph problem. You are given an array, a variable pair equation, and an array of real number values where the equation a, b, and the value I represent equation of a divided by b with the value I. Each a and b is a string that represent a single variable. Okay. So you are also given some queries where query C and D represent a J query where you must find answer for C divided by D. So we need to return all answer to the queries. If there's no answer, we return -1. Okay. So for this problem, the only thing we need to care about right here is, let's say we have equation a and b. It's meaning that we have a divided by b, and the value right here is 2, so this is equal to 2. And we have b and c right here, so b divided by c, which is equal to 3, something like that. For the query, let's say we have a query a and c in here, right? For this query, a and c is meaning that a divided by c, so what is that number? And then the answer is 6. So imagine you take a divided by b, multiply with b divided by c. You cancel the b out, you will have a on c, which means you have 6 right here, right? So a divided by b is 2, b divided by c is 3. So a divided by c right here, because we cancel the b out, we have 6. So, and then in the queries, there's one more thing that you need to think of your head, is b divided by a. So when a divided by b is, let's say 6, oh my bad, not 6, it's 2, right? So what is b divided by a? So we switch this, right? We multiply each side with, actually we divided each side with 1, right? So a and b is go backward like this. Okay, something like that. So that's why it is 0.5, which is 1/2, something like that. So it's involved a little bit math in there. Okay, so in the first place, I telling everyone that, oh, this is a graph problem, so I can demonstrate it for you. So as you can see right here, we have the draw it out an adjacency list, right? Let's say we want, and this for this problem we're gonna use BFS. Let's say we want to looking for a query a divided by c, right? So we start with a and we find c. Okay, so start with a, we have a neighbor of b and the weight 2, meaning that a divided by b is 2. In the traverse, we're gonna keep track of one variable, I just call it product. Right. So at the first start, we have we start at a, and the product is right now is 2. So now we go to b, and then we'll find its neighbors. So we from here we go to b, right? And then right now the current node is b. We already visit a, so we don't visit again, but now we have c. Go to c. So the product right now is gonna be multiplied by 3 since we are at c, and this one is now c. Okay, and the c in here is the goal, so we return the product as 6. Yep, so something like that. So just traverse and then figure out the products. But it will make more sense in the coding. Okay. So first of all, we will have I will start with equal to the length of the equation, right? And then we have my adjacency list, which is the default with a list. Then for I in range n, we will have the destination and the source, which is standard BFS equation 0 and of 1, something like that. Then we have a weight, which is gonna be the value. And then also the adjacency, BFS, append the destination and the way. And I also need to do backwards. So this is the sort. Oh, for that sort destination. So it should be backwards. And then the opposite. So when we do opposite, we have to make it. We have to take 1 divided by the weight. So let's print it out, see if the efficiency list looks correct. Let's see. Yeah, efficiency look correct. So A, B equal to A equal to C, and then C equal to B with 0.333. So expected. Right now we have the length of the queries. So right, and our result is gonna be equal to that length too. So now the font star length cube. Okay, so we have to go through every single queries to ask for it, right? So for this query, it's gonna be in range of length q. So we have source, destination of the queries. We have the result of I. So for every single queries, we need to find, okay, is it a negative one? Is it findable? And we find values. So I will use a helper function called BFS. So this is where we use BFS to traverse adjacency list. So we put the sort in there. We put the destination in there. The sort will be our starter point, and then our destination is gonna be our goal, endpoint. In the end, we just return our result. And right now, we do some BFS. Let's say we say start, this is end, right? So if the start is not in the adjacency list, meaning that there's nothing to start with, we just return -1. Because in this example, we have recorded of XX, which is never found in this adjacency list. So there's nothing to do there. Yeah. And then we have our DQ as a DQ standard q.append sort and 1 right there. We have our visit set, right? we add add the source at the start. The source start. So YQ or in range length of Q. We will have our node and the current product, right? Which is when it pop left. If a node is gonna equal to the end, right? If our node equal to the end, we just return the current product. So we found our we found the end right there, and we are able to calculate the product for neighbor in the case we don't find it. For neighbor in adjacent to this node, I have my neighbor node, and I also have my neighbor weight, which is from neighbor. So if my neighbor node is in visit, we skip it. We don't have to deal with it if it's already in visit. And then Q append. This is when it's not in visit, we append it to the adjacency list. So neighbor and current product multiply with the neighbor weight, something like that. In here, we also need to add our neighbor node into the set, into the visit set, right? So right there, and if the queue is empty, we never return any product. We return -1 because we do not find anything. So let's run this one. Yep, it's work. Looks pretty cool, and this work. So for time complexity, since we have every single node, basically we have to go through every single node is n, and we multiply with q, because q is the length of the query. So for every single queries, we have to call our BFS, and the space complexity is the same. Also q times q, something like that. All right. So hope if you like video content, please like, subscribe, and see you soon on the next video.